All right, today we are learning about adding integers. And the vocab words that we need to know with this is the word integers, of course. If we're adding them, we need to know what they are, and additive inverse. So, integers, we defined it yesterday, we'll define it again. They are whole numbers and their opposites, also known as just positive and negative numbers. When I say whole numbers, I think whole, and if I had a whole, it would be like a circle, which is 0. Whole numbers are 0, 1, 2, 3, all the way to infinity. That's my whole number part, and their opposites would be the opposite of 1 is negative 1, negative 2, negative 3, all the way to negative infinity. Additive inverse, they are opposite integers where the sum is equal to 0. Opposite integers where the sum is equal to 0. The sum is equal to 0. For example, negative 2 and positive 2 are additive inverses because negative 2 plus 2 is 0. 3 plus negative 3. They are additive inverses. Negative 22 and positive 22 are additive inverses because their sum is 0. Anytime if you add two numbers together and their sum is 0, they are always additive inverses. One of the first concepts with integer operations with adding that you need to be familiar with is a visual with integer chips. Integer chips are funny. We don't bring them out too much. They used to be like a really popular way to show it adding integers, but they just kind of lost their feel. But the MCA still puts these diagrams on their test, so you want to make sure to have been exposed to it. So, red. The color red is negative. And how I think of that, when I think of red, I think red is stop, danger. And it's negative if you have something going on that's telling you to stop. It must be a negative thing, okay? Like fire. Fire is red and dangerous. Yellow then would be what? Positive, like the sun. Yay, the sun is positive. Makes us happy as long as we protect our skin from the sun. How you're going to be exposed to it on a standardized test, they give you an example like this first one, where they're going to say, write a numerical expression that goes along with that model. And you just show the sum. You say, okay, I have two negatives, so I'd say negative 2. I have 2 of them. Plus, because you're adding to it, 3 positives. That is the numerical expression that goes along with that model, the integer chip model. Now we can find the sum. The yellow and the red are additive inverses, so look at what happens. It cancels. It cancels. I'm left with 1 positive. The next one I want you to write a numerical expression for. What do we get for this next example? Andrew?
Negative 5 plus 3 plus negative 2.
I have 5 negatives, 1, 2, 3, 4, 5, plus 3 positives. And what does that equal? If I want to go generic, I cross out the additive inverses. I am left with 2 negatives, so the sum of that is negative 2. You can always model an integer addition with integer chips, always. You could do that. So if you ever feel stuck on one, you can definitely draw it out. Next page. The next visual that we do is using a number line, one of my least favorites, but we'll get through it. Here, for the number line, we are representing a football play, creating a number line. It says on 2 plays, a football team first loses 8 yards and then gains 3 yards. So we want to find -8 plus 3 to find the total yard gainage. Okay? What they tell us, this would be like our first step, it says start at 0. And then we're going to -8. We lost 8 yards. So we're going from here, you're going 8 to the left. Anytime you are negative, you're going to the left. So you're at 8-yard loss. Well, then you run up 3 yards. And when you gain, you go to the right. So I gain 3 yards. I'm left at that -5. That is my answer. How we do it, the steps. Modeling with number line. The first thing you do is start at 0. Always start at 0. The second thing you do, go to the first number. Whether you go to the left or to the right, you go that many spots to the left or right. And lastly, third, we go to the last number, moving from the left to the right. Example, 3 plus -7. First, start at 0. Where's 0? Here it is. That's where I'm starting, 0. And it says that my first number is 3. 3 is positive, I go to the right. So I'm going to the right, 1, 2, 3. There I am. Now from there, I'm adding a -7. -7 tells me I go to the left, so I'm going to go to the left 7 spots from this 3. So 1, 2, 3, 4, 5, 6, 7. That would be right there. And where I end up is my answer. My answer is -4. -5 plus -2. I start at 0. I go to the left 5. 1, 2, 3, 4, 5. And then I'm adding a -2, so I'm going to the left again. Negative means left. So I'm going 2 spots to the left from the 5. I end up right here. My answer is -7. 2 visual models I showed you, integer chips, number line. Both will be checked and assessed at some point in your 7th grade life. This is the way we normally do it. We just follow the rules, okay? So, the integer addition rules without visuals or models. If they're the same sign, all you do is add them up and make it the sign they were. So you add them up and make the same sign. That's it. Add up, make the same sign. If they're different signs, you're going to want to take the difference and determine which one is further from 0. And you will see that in action. It's hard to explain that with words. You'll see it as I go through these examples. -3 plus 12, same or different signs? Same. So I add them up. 3 plus 12 is 15. Make it the sign they were. 32 plus a -7, same or different? Different. So I take their difference, so I go 32 minus 7, that's 25. And then I ask myself, which one is further from 0, the positive or the negative? And it's the positive 32, so it stays positive. Okay? So whichever one is furthest from 0, that sign wins. -23 plus 18, same or different? Different. Take their difference, 23, take away 18, that's 5. Now I ask myself, which one's further from 0, -23 or positive 18? The negative, right? Since the negative is further away, the negative wins and it's -5. 3.01 plus a -1 1.7. I take their difference because they're opposite signs. Remember when you do decimal operations, if you're adding or subtracting, you line up the decimal. So it's 1.31. This one's 3 away from 0. This one's 1.7 away. The positive wins. So it's a positive answer. Yep.
Shouldn't it be 1.29?
No.
No.
Never mind. Sorry.
Okay. Fraction examples. Make sure, the first thing you want to do is make sure they have a common denominator. I'm going to just write common denum since I took so much space. And then I follow integer rules. All right. This is so much fun. Oh my goodness. Okay, first one. I need a common denominator. I'm going to make my common denominator what? 60. That's just the first thing that popped into my head. Maybe there's a smaller one. I'm just going to roll with 60 though. 20 times 3 is 60. 3 times 3 is 9. 3 times 20 is 60. 1 times 20 is 20. Throw the negative out. Okay? I just put the negative out front. This is negative 20 over 60 plus 9 over 60. They are opposite signs, so I'm going 20 minus 9, which is 11, and then I'm asking myself, which one is further from 0? Negative 20 or positive 9. The negative 20 is further from 0, so I'm going to be negative. Final answer is negative 11 over 60. The next fraction is how you're going to see it on any Google assessment that I make. The fractions are written as a slash. Okay, I always just rewrite it. Negative 4 sevenths plus a negative 3 14ths. I like mine nice and straight. 14 is the common denom. 7 times 2 is 14. Negative 4 times 2 is negative 8. So I have negative 8 over 14 plus negative 3 over 14. They're the same sign, so I add them up. 8 plus 3 is 11. Keep it negative over 14. That is integer addition.